This is continuing on with section 6.5 out of pre-calculus, multiplying these two different trig numbers. First off, we're going to multiply the numbers on the outside to give us 6, and then we're going to add the numbers on the inside, so it's cosine of 45 degrees plus I times the sine of 45 degrees. Next, we're going to simplify. 45 degrees is special. The cosine of 45 is the square root of 2 over 2. Plus, and the sine of 45 is also square root of 2 over 2. Then we'll distribute that 6. 6 times root 2 over 2 is 3 square root of 2. And then 6 times I square root of 2 over 2 is plus 3I square root of 2. So there's our number now in rectangular form. First problem with division, and division is the inverse operation of multiplication. So when we divide, we actually divide the outside numbers. 8 divided by 2 is 4. And instead of adding the inside numbers, we would subtract them. So 5 pi over 3 minus 1 pi over 3 is 4 pi over 3. So this is what it's going to look like once we actually do the division. Now let's simplify the inside. The cosine of 4 pi over 3 is negative 1/2. The sine of 4 pi over 3 is negative root 3 over 2. Now distribute the 4 to both of those terms, and we end up with negative 2 minus 2I root 3. One more with division. Negative 9 divided by 6 is negative 3/2. When you subtract those angles, you need a common denominator. 3 pi over 4 minus 2 pi over 4 would give you 1 pi over 4. Just one like this. Pi over 4 is 45 degrees. So the cosine of pi over 4 plus I times the sine of pi over 4. And now distribute, and we're going to have negative 3 root 2 over 4 minus the I root 2 over 4. We're going to look at De Moivre's theorem, and De Moivre's theorem tells us how we take a trig number to a power. So if we took our cosine of theta plus I times the sine of theta times itself n times, we could expand it with this formula. We always were multiplying the number on the outside by the other number on the outside. So if you're multiplying r times itself n times, it's r to the n. And we'd add the angles on the inside. So if you're adding theta plus theta a total of n times, you have n theta. So again, this is a way that we can take one of these polar trig numbers to a power without having to multiply it by itself that many times. First example, we want to multiply 2 minus 2I to the 6th. Now, I will tell you that this can be done on a calculator, be done very quickly, but I want to go over the skills on how to use De Moivre's theorem for this one because it's going to help us as we get into taking roots, which the calculator can't do. First off, this number is in rectangular form, so we have to get it into the trig form. 2 squared plus 2 squared, and then the square root of that. The radius is 2 square root of 2. And then theta, 2 negative 2. This reference angle here has an opposite over adjacent, so we take the tangent inverse of negative 2 over 2. The calculator would give us negative 45 degrees, but I can see from the drawing that it's going to be 360 minus the 45 for 315 degrees. This number that we have could also be written as 2 square root of 2, and I'm going to go back and just call it square root of 8 cis of 315 degrees. So these two terms are equivalent, they're just in different forms. But in order to use De Moivre's theorem, we have to have it in this trig form. So we're taking this number to the 6th power. And using De Moivre's theorem, it's supposed to be the number on the outside gets taken to the 6th, and then the number on the inside gets multiplied by this. So 6 times 315. And now let's expand this out. The square root of 8 to the 6th, that's the square root of 8 times the square root of 8, a total of 6 times. Just for the sake of time, I'll tell you that's 512. And then 6 times 315 degrees is 1890 degrees. Cis 1890. Obviously a huge number, so we can subtract 360 and keep unwinding it, minus 360, minus 360, and eventually get it into a coterminal angle that's much smaller. It would reduce all the way down to 90 degrees. So from here we can go closer to our answer. The cosine of 90 degrees is 0. The sine of 90 degrees is 1, so it's plus 1i. Now distribute the 512, and we'll get an answer of 512i. For this next one, I'd encourage you to pause the video and see what you can do on your own. We have this number in rectangular form taken to the 4th power. You're going to want to convert it into trig form and then start using de Moivre's theorem. So again, pause it. I'll be working through the problem here in a moment, but pause it and see what you can do on your own first. Right, so the radius a squared plus b squared, and the square root of that gives us a radius of 4. That's how far away this point is from the origin. The tangent inverse of 2 root 3 over 2 gives us that theta is 60 degrees. And it really is 60 degrees. I can tell because it's in the first quadrant. So this problem then becomes 4 cis 60 degrees to the 4th power. Means we're going to take 4 to the 4th and multiply 4 times 60 degrees. The cosine of 240, negative 1/2. The sine of 240 is negative square root of 3 over 2. 4 to the 4th power is 256. When we distribute this, we're going to have negative 128 minus 128i root. Here's our last problem with just using de Moivre's theorem. And again, I encourage you to stop the video and try this on your own. You're going to need to figure out the radius and figure out the angle. So pause it, work through it, and then you can check back. And I'll tell you that the final answer comes out to 128 minus 128i. The radius was the square root of 8 again, and theta this time was 135 degrees because it was in quadrant 2. Before we get into the roots, just to note, the cube root of x means it's x to the 1/3, or if you have x to the 3/5, that means you're talking about the 5th root of x to the 3rd. So just a small note there. So as we were talking about earlier, when you have a polynomial, the highest degree tells you how many roots it should have. And if we have x to the 5th plus a bunch of other things equals 0, this is still a complex number. The imaginary part is 0, and it's not in polar form, but it should have 5 roots, and we need to be able to find all 5 of them. And if we convert these different numbers into the polar form, then we're able to find all of the roots that are necessary. And here is the formula for that, which looks like kind of a confusing formula. So instead of trying to explain all these little details, let's just go into an example and see how it practically works. So in this one, we want to find all the cube roots of 8i. What are the 3 different numbers that multiplied by themselves 3 times that will give us 8i? First off, we're going to convert this into a trig number, and 8i goes straight up by 8. So its radius is 8, its angle is 90 degrees. So as a polar number, we have 8 cis 90 degrees. And we're finding all the cube roots of it. In other words, we're taking this to the 1/3 power. And using that formula, what it means we need to do is 8 to the 1/3, and then also multiply 1/3 times 90, or 90 over 3. Simplifying this just a little bit, 8 to the 1/3, that means the cube root of 8, well, that's 2. And then 90 divided by 3 is 30, so it's the cosine of 30 plus I times the sine of 30. And for these values, the cosine of 30 is square root of 3 over 2. When we multiply that by 2, it will just give us the square root of 3. The sine of 30 is 1/2. 2 times I 1/2 will give us plus I. This is one of our answers. In your calculator, if you enter in I plus the square root of 3, and I is one of the options along the bottom row, so I plus the square root of 3, hit equals, raise it to the 3rd power, and you would get 8i. but there are more answers to this. I'm going to go back up to this red row, and it's going to be 8 to the 1/3 cis of not 90 over 3 this time, but 90 plus 360. In other words, we're adding a complete cycle to it and dividing it by 3. We take whatever angle it is we have and add 360 to it to come up with a second answer. So again, 8 to the 1/3 is 2. 90 plus 360 is 450. 450 divided by 3 is 150 degrees. So it's 2 cis 150 degrees. The cosine of 150 degrees is negative root 3 over 2. So 2 times the cosine value, 2 times the cosine value is going to give us negative square root of 3. 2 times the sine of 150, well, the sine of 150 is 1/2. So 2 times the 1/2 I will give us plus I. Very similar answer to the first one, but it is different. So again, if you go to your calculator, negative square root of 3 plus I equals, then raise it to the 3rd power, it'll give you 8I. But these are cube roots. We need 3 answers. So we have 1 answer, 2 answers, 3rd answer. Once again, we're going to have 8 to the 1/3 cis of 90 plus. So we're going to take this answer, add another 360 onto it. It'll be 90 plus 720. And divide that by 3. 8 to the 1/3 is still 2. 90 plus 720 is 810. 810 divided by 3 is 270 degrees. The cosine of 270 is 0. The sine of 270 is negative 1, so 2 times negative 1I gives us negative 2I, and those are our 3 answers. Those are the 3 cube roots of 8I. Okay, this time the number is given to us in trig form already. We need to find the square roots of 64 cis 60. So we want to take this number to the 1/2, that's the square root. So 64 to the 1/2 cis of 60 over 2. So 1/2 is a power for the number out front for our radius, and it is also then multiplied by the angle that we have. 64 to the 1/2 is 8. 60 divided by 2 is 30. And so now we can evaluate. The cosine of 30 is root 3 over 2, so 8 times the cosine is 4 root 3. The sine of 30 is 1/2. 8 times 1/2 I is plus 4I. There's one of our answers. And this time we're talking square roots, so there's only 2 solutions. So to find the next one, we'll take that blue line, write it out again, but the only difference now is we have 60 plus 360 divided by 2. So once again, this is where we're getting this coterminal angle, adding 360 onto that angle, and now evaluating from there. 60 plus 360 is 420, divided by 2 is 210, so 8 cis 210. And when we evaluate that, we should get an answer of negative 4 root 3 minus 4I. So those are our 2 answers for this problem. If you were to take any one of them individually, enter this into your calculator, and then square it, we would get the equivalent answer at the beginning, and since it's in polar form, it's hard to verify that one. The problem is going to take a little bit more time, so I'd encourage you to pause it, see if you can figure out how to convert this rectangular number into the trig form. You're going to need to draw it, figure out its radius, figure out its angle, and then see if you can go through the process. Again, pause the video. I'll work out the problem here in a moment. Pause it, see what you can do on your own first. So find the radius. A squared plus b squared, the square root of that is going to give us that the radius is 8. And the tangent inverse of opposite over adjacent gives us that this angle is 45 degrees. Because of that quadrant, we're going to take 360 minus 45 to get 45 degrees, 315 degrees for our angle. So we're taking the cube root of 8 cis 315 degrees. In red, I have the 3 different row or columns set up for the 3 different answers we're going to get. Now in my next step, I'm going to be figuring out how these simplify down just a little bit. So in this green, I have them all simplified down. And one thing I noticed is that I have 105 degrees. That's not one of our special angles. It can be derived from those other ones, but at this point, I would say that is good enough. So we have these 3 answers that are the cube roots of that initial.